This is the most advanced fighter jet ever built, without any competition ever showing up since it first took flight in 1997. It in fact wasn't until 2023 that the F-22 Raptor had its first ever air-to-air combat, where she shot down a Chinese spy balloon off the coast of South Carolina, and she came out of that dogfight without a scratch. The fact that the US government never approved to sell this aircraft to any other countries, even the United States' closest allies, speaks volumes as to how amazing of an aircraft it truly is. The F-22 Raptor, as you can see, is super maneuverable. And at the same time, she has the stealth capabilities of an F-117 Nighthawk. But how thrust vectoring technology makes the F-22 more stealthy? The real reason why the aircraft has a golden canopy, why the United States exports the F-35 but still has a ban on F-22 export, even though the F-35 in some ways is more advanced, and why despite being the GOAT, the F-22 Raptor is no longer produced, is not what you think. It's a combination of three areas that makes the F-22 Raptor so unique: speed and maneuverability, stealth, and advanced avionics. It's not just that the F-22 can fly supersonic. The Raptor was the first American fighter with the ability to supercruise. In this context, supercruise is defined as the ability to cruise at Mach 1.5 or more, but without using afterburners, and for extended periods in combat configuration. But why is this important? Prior to the F-22, virtually all fighter jets could only cruise at under Mach 0.9 while carrying a normal weapons load. They could fly supersonic, but only with the afterburners. The thing is, the afterburner plume reflects radar signals and creates a significant infrared signature. And for a stealth aircraft like the F-22, that's a big no-no. Supercruise allows the Raptor to be supersonic without making it shine on enemy radars. But how did the F-22 accomplish this? The speed advantages of the Raptor is thanks to two massive Pratt & Whitney F-119 engines. Each engine can deliver 35,000 pounds of force. A derivative of this engine was later used to power the F-35 Lightning by producing up to 43,000 pounds of thrust. But aside from the raw power, each Raptor's engine also has a nozzle that is capable of thrust vectoring. Thrust vectoring started out as a solution to VTOL, vertical takeoff and landing. The British Harrier was the first fighter jet that used thrust vectoring. By directing the engine thrust downward, the aircraft could get off the ground vertically. But the Harrier's thrust vectoring was not intended to influence the maneuvering of the aircraft in flight. It wasn't until the 1990s that an experimental jet fighter was designed specifically to test fighter thrust vectoring technology. Designed and built under a joint US and German program, the X-31 could safely perform maneuvers that would be impossible or deadly for any other aircraft to do. And it was all thanks to thrust vectoring and the advanced onboard computers that controlled the airplane. It was with the help of lessons learned from the X-31 and also programs like HARV, where a modified FA-18 Hornet used thrust vectoring and actuated four-body strakes, that the ultimate fighter, the F-22 Raptor, was designed and produced. The F-22 can perform maneuvers like the Cobra and the J-turn. These maneuvers allow the aircraft to evade homing missiles launched from enemy air defenses and fighters. Of course, the F-22 pilot is unlikely to find themselves in such dangerous situations, because the Raptor is stealthy as fog. When it comes to stealth, the designers of the F-22 already had a lot of experience. Since the 1980s, Lockheed had already been experimenting with stealth in the F-117 Nighthawk program. Back then, the understanding of stealth was based on the theory that sharply angled panels could reflect and disrupt radio waves, resulting in an inaccurate signal picture for the observers at the radar station. But stealth technology is not just one thing. It's a set of technologies used in combination to greatly reduce the distances at which a vehicle can be detected. This includes reducing the radar cross-section, but also lowering acoustic, thermal, and other aspects. By the late 1980s, radar-absorbing materials had become available to the US defense contractors. This meant that stealth aircraft such as the B-2 and later the F-22 could have curved surfaces, which was more aerodynamic. The first order of business is to shape the aircraft so that no energy can reflect straight back to the source. That's why you won't find any 90-degree angles on the F-22. Right angles send radar signals straight back to where they came from. This is also why you don't see any weapons carried by the F-22, as they could reflect back the radar signal. You don't see the weapons because they're all hidden inside the aircraft's internal weapons bay, which only opens up for a moment to launch the weapon and then closes back up, similar to how the B-2 stealth bomber drops bombs. The canopy of an aircraft, if not treated, would allow radar energy into the cockpit, where it could in turn be reflected off all the stuff inside and back to radars. To prevent this, the F-22 canopy is coated with a thin layer of indium tin oxide, which happens to give the canopy a golden tint. This leaves the canopy see-through to the pilot, but opaque to radar, and the shape of the canopy reflects the signals away from the radar. After that, LO or low observable coatings is part of what makes the Raptor stealthy. Every night after the jet comes back to the base, they're parked in hangars. Each Raptor is then inspected for about 45 minutes to look for and mark any new damages to the stealth coating. Fixing the LO coating consists of picking panels, painting, sanding, and using sealants to cover gaps. Because radar absorber materials require a lot of maintenance, their application has been limited to only places on the airframe where they're needed the most. Unlike the B-2 stealth bomber, which requires climate-controlled hangars to maintain its delicate stealth properties, the F-22 can be worked on in any average hangar. But even then, about 50% of the maintenance performed on the F-22 is related to repairing the LO stealth coatings that are damaged when the aircraft is opened up for routine maintenance. But what about the flight control surfaces? Wouldn't they reflect signals as they move? Even though some signals may bounce back from the flaps, this exposure is minimized with the help of thrust vectoring, because by directing the jet exhaust, less flight control surface movements are required. And that's why thrust vectoring not only makes the F-22 more maneuverable, but also more stealthy. It's these features and much more that makes the radar cross-section of F-22 to be the size of a small steel marble. The Raptor is even visually kind of stealthy, especially when looking at it head-on. The third and final edge the F-22 has over almost any other fighter is its avionics suite, with only its close relative, the F-35, having better electronics due to being newer. The F-22's onboard radar and targeting system are so advanced that give the Raptor first kill opportunity. This means the aircraft will see and shoot down its target before the target is even aware of the F-22's presence. Combine the first kill opportunity and the stealth, and chances are the Raptor would never have to use its super maneuverability to avoid being shot. But hey, at least it can put on a great performance at the air shows. But let's take a step back. Why does this airplane even exist? With the United States fighting exclusively asymmetrical wars since the 1990s, there haven't been any worthy adversaries for the F-22. The thing is, the need for such an aircraft came during the 1980s, when the Soviet Union had begun ramping up their air combat capabilities with aircraft like the Beriev A-50, MiG-29, and Su-27 fighters, with the last two being classified as super maneuverable. Up until then, American fighters like the F-15 and F-16 held massive maneuverability advantages over Soviet fighters. These American fighters did not fear detection from the Soviet ground-based radars during dogfights, believing they could dodge surface-to-air missiles using their flares and high-G turns. Once it seemed like Soviet technology was catching up, the effort to create a fighter to surpass the opponents began. By the 1990s, two potential fighters were proposed by two of the biggest military defense contractors, Northrop and Lockheed. Northrop offered up the YF-23, a large but highly sophisticated aircraft with no horizontal stabilizers and a diamond-shaped body. Lockheed, on the other hand, with much of its stealth wisdom coming from the F-117 program of the 1980s, proposed the YF-22, which had a more conventional format. Unlike the diamond wings of the YF-23, the YF-22 had trapezoidal wings and large independently moving horizontal stabilizers. Northrop's YF-23 was faster and stealthier, but Lockheed's YF-22 could carry more munitions internally and was more agile for potential dogfights. So what tipped the scale toward Lockheed, which eventually won the contract in April of 1991? See, Northrop was already having cost overrun issues on the B-2 bomber project, and that tipped the decision toward Lockheed. Ironically, Lockheed's F-22 ended up being quite an expensive project. Only 8 months after the F-22 was announced as the new air superiority fighter of the US Air Force, America's biggest rival, the Soviet Union, collapsed. Suddenly, the US Air Force found itself funding the purchase of 750 state-of-the-art airplanes, with no enemy on the horizon. Over the years of development and testing leading to its official introduction in 2005, the Air Force would lower the amount ordered from 750 all the way down to 195. As the F-22 production wound down in 2011, the total program cost was estimated to be about $67.3 billion, with $32.4 billion spent on R&D and testing and $34.9 billion on procurement and military construction. The incremental cost for an additional F-22 was estimated at $138 million in 2009. The F-22 program also took a hit when the Navy announced their pullout from purchasing any F-22 naval variants, and the reasoning was simple. They were too expensive to procure, and their cost per hour of flight time was $70,000. For comparison, the estimated cost to operate an F-35 is $44,000 per hour. In October 2018, 8 to 12 Raptors were damaged at Tyndall Air Force Base in Panama City when they took a direct hit from Hurricane Michael. That was a sizable chunk of the F-22 fleet that was damaged, but they've been repaired since. The US government also prohibited the sale of the Raptor to any foreign countries due to the sheer technological secrecy of all of the Raptor's systems and performance. Shortly after the completion of the F-22 development program, the US Department of Defense announced the Joint Strike Fighter program, which would eventually result in the F-35. While visually similar to the F-22, the F-35 would become a slower, less agile, jack-of-all-trades type of aircraft that would not be as avionically complex or stealthy as the F-22, allowing for international export. All that said, the sun is already setting on the Raptor's dominance, but not because of rival aircraft like Russia's Su-57 or China's J-20. It is the Raptor's own replacement that the United States is currently working on under a program called Next Generation Air Dominance or NGAD. This is a 6th-generation air superiority platform designed to be highly integrated with drone support and the most modern avionics, and is estimated to be ready for service by 2030. And maybe even then, the F-22 will remain the fastest, most maneuverable, stealthiest aircraft of all time.